In lesson 9.3, we'll be looking at some transforming of data by adding or subtracting things or multiplying data sets by something. And our main goal for this is to get to the idea of a Z-score, which is an important idea in statistics. It kind of standardizes the standard deviation. So we're going to investigate a couple things first. So let's go ahead and consider the following quiz scores. We have a 4, 6, 7, 9, 9, and 10. Now I'm not going to do all of the work, but we could find the mean of this, and then we could find this standard deviation. So this does take some time to do this. Finding the mean, you add the 6 values together, divide by 6, and then you would subtract your individual score, mine, and then subtract the mean from that. Add those all together, square them, then add them all together to get your sum of squares, and then you can divide by n minus 1 to get your variance, and then take the square root of that to get your standard deviation. But knowing we can do all of those things, I'm just giving you these two things. So the mean is 7.5 and the standard deviation ends up being 2.26. So let's think about this. If we added 5 to each quiz score, so add 5. 5 plus 4 is 9. 6 plus 5 is 11. 7 plus 5 is 12. 9 plus 5 is 14, and then the 10 plus 5 is 15. So we added 5 to each score. What is that going to do to our mean and to our standard deviation? Well, if you add 5 to everything, the mean is going to go up by 5, but our standard deviation is going to stay the same because it still has the same spread. Things are still spread out the same way. 9's our lowest, our highest, so the range is still the same. Out the same between the 6 things. So the standard deviation will remain the same. So we answered those two questions. The mean will actually go up by 5 and the standard deviation will remain the same. This brings us to a theorem. Several x values that represent your original, and you have the same amount of y values that are obtained by adding the same number. So in our last example we added 5. So the same constant k to the original, then the mean will be just take the original mean and add that constant, but the standard deviation of the new set will equal the standard deviation of the original. So in other words, the constant can be added to the mean to get the mean of the x values to get the mean of the y values, and the standard deviations will be the same. Well, that's adding. Now let's think multiplying. Consider what happens when you multiply each score by the same thing. So here we have our 4, 6, 7, 9, 9, 10. We multiply by 3. 12, 18, 21, 27, 27, and 30. If we found the mean of this, so if we went back through all of our data and did this stuff, add these all together, divide by 6, we would get 22.5. Work through finding our standard deviation. We would get 6.77. So how do these compare? Well, the mean is 3 times more. So in order to get the new mean, you multiply the original by 3. And the same idea holds true for the standard deviation. Our scores actually get more spread out. They get spread out by a multiple of 3. So here's the theorem. Multiplying by the same constant k, your mean will be multiplied by that constant, and the standard deviation will also be multiplied by that constant. So here's the idea of a z-score. A z-score is really important, and we'll talk about that in a minute, but the z-score is the transformed score found by subtracting the mean from the individual score and then dividing by the standard deviation. So this is talking about an individual score. So if a bunch of people take a test, you have a mean for that test, and if one person wants to look at, well, how did they compare to everyone else, they could find the z-score. The statistic Z is a measure of the deviation of an individual score from the mean in units of a standard deviation. And so what that means is the mean Z-scores, if you found the mean of all the Z-scores, would be 0. And what's really helpful is it sets the standard deviation to 1. So you can talk about, well, I was 1 standard deviation for the mean, or 0.5 standard deviations from the mean. And so we're going to do just a couple examples finding Z-scores, and again, this is a very helpful score. So Mary got a 9 on her quiz, the class average was a 7, and the standard deviation was 1.5. How many standard deviations away from the mean was Mary's score? So we're just looking for Mary's Z-score. And so what we want to do here, our equation right here for Z-score, Z is the individual score minus the mean divided by the standard deviation. So we want the Z-score, which is the individual score minus the mean divided by the standard deviation. Well, we have all these values. So this is going to be her score, which is 9, minus the average, which we knew was 7, divided by 1.5. So this is 2 divided by 1.5. And so her Z-score is about 1.3. It's 1.25. And so that's her Z-score. Nice and simple. Next one, John scored a 79 on his test, having a mean of 84 and a standard deviation of 4. Find his Z-score. Well, we'll do the same thing. We know that Z-score is equal to the individual score minus the mean divided by the standard deviation. So in this case, we have his score minus the mean divided by the standard deviation of 4. 79 minus 84 is negative 5 over 4, and we get negative 1.25. So he was 1.25 deviations lower than the mean. So important idea here, negative means your score is lower than the mean, and in the previous example with Mary, hers was positive, so it was higher than the mean score. And so that's the idea of Z-score.